Solutions will be given a list of specific angles when given a restriction. So, right, you give me a specific list, right? It's not plus or minus if there's a restriction. And it also says, don't forget if you take a square root to consider plus and minus. If you drop off that plus minus, then you're eliminating some of the potential answers there, right? You're losing some solutions if you don't consider the plus minus. Okay. All right, so on example number 1, this one is given over a specific domain, right? It says it only goes from 0 to 2 pi, and it says the 2 pi is not included, right? The 0 is included, 2 pi is not included. So, if we were going to solve this, this looks like something that should factor, right? So, I make my factors, and I ask myself, whatever I'm going to put here and here has to multiply to give me 2 sine squared. So what multiplies to give us 2 sine squared? 2 sine and sine. So I have 2 sine of x and sine of x. All right, and what multiplies to give us 1? 1 and 1. And then when I'm trying to decide what my signs are going to be, we look at this middle term. And it's negative sine of x. That's like negative 1, right? So that means I'm going to want more negatives than positives. So where are my signs and what are they going to be? Right, because inside would give us a positive. Outside would give us 2 negatives. That would give us that negative 1. Okay, perfect. And now that I have 2 factors, to solve them, all I have to do is set them equal to 0. So I'll have 2 sine of x plus 1 equals 0. And sine of x minus 1 equals 0. All right, so for that first factor, when we solve, what do we end up getting? Right. Sine of x equals negative 1/2. All right, so I'm asking myself, because sine is number of fingers to the right if I'm using my hand, which finger do I bend if I want there to be 1 finger to the right? 1 finger to the right. To the right. Which would be 30 degrees or pi 6, okay? But it does say that we're looking for where sine is negative, right? So what quadrants does that occur in? 3 and 4, okay? So what's a multiple of pi 6 in quadrant 3 and 4? Not 7 pi 6. Oh, wait, yes, 7 pi 6, yes, for quadrant 3. I'm looking at my quadrant 4 answer here. And 11 pi 6, okay? So x equals 7 pi 6 and 11 pi 6, right? All right, and then let's see if we can come up with any more solutions based on that other factor. So when I solve my other factor, what do I get? Sine of x equals 1. Okay? So sine of x equals 1, where is that going to occur? Pi halves, and pi halves only, right? I don't put plus or minus on this answer because they said it was over a specific domain, right? Not continuous. All right? Okay. Example number 2. This one did not give us a domain, right? It's not restricted. So this would be one of those answers where we might need to put plus or minus some specific amount. Okay, so for example number 2, we've got 2 cosine of 3 theta minus 1. So let's just work on getting the cosine of 3 theta by itself. What would we do? Add 1, and then we would divide by 2. So I'd have cosine of 3 theta equals 1 over 2, right? So I'm not going to worry about the 3 theta right now. I'm just going to deal with that 1/2. So that means I've got 1 finger to the left, right? Since I'm talking about cosine. Pi over 3, okay? And it does look like we're talking about where cosine's positive, since that's a positive 1/2. So where else is cosine positive besides quadrant 1? 4, Okay, and a multiple of pi thirds in quadrant 4 would be 5 pi thirds. Good. Okay, and now this is where I have to worry about that 3 that was in there, because this would mean 3 theta, or 3x, is equal to that pi thirds, right? Or that 3 theta is equal to that 5 pi thirds. So how do we get rid of that 3 in front of the theta? Divide by 3, which is the same as multiplying by 1/3, right? So I'm going to multiply by 1/3. Okay. So we end up getting what? For that first one, we're going to get pi ninths. And then for that other one, we're going to get 5 pi ninths. Okay. All right, so this is where I would need to consider plus or minus, right? So that pi ninths plus or minus, right? Okay, so cosine's normal period is 2 pi, right? And I said it's typically always going to be 2 pi, especially in this case because they didn't say they wanted positives and negatives, so we are skipping some spots, right? But since we went and multiplied all of these values by 1/3, we would also need to multiply our period by 1/3, right, to change how much it's changing by. So 2 pi times 1/3 becomes 2 pi over 3. So plus or minus 2 pi over 3n. Okay, and then for this other one, we would get 5 pi ninths, right? Plus or minus that same period, right? So those would be our two solutions. And I use n, guys, but you could use any variable there, just to show that it's some multiple number of times.
So the only time that you would change the period is when you have something attached to like the theta.
Right, right. If you got something in here that you're changing your actual values by, you need to also change your period by it. Okay?
But if like theta was isolated, then
yes,
you don't change your period.
You don't have to do that,
Okay.
No. Okay? All right, so number 3. I need to solve for tangent of x over 2. So what am I doing first? Minus the 3, and then divide by 3. So negative 3 divided by 3 is going to give us that tangent of x over 2 is equal to negative 1, right? Okay. So I'm asking, where is tangent negative 1? Well, tangent is y over x, right? So is there anywhere where that happens? Where does that happen at? Quadrants 2 and 4, okay, because it's negative, all right. So then in quadrant 2, so 3 pi fourths, and then in quadrant 4 it would be 7 pi fourths. Good, okay. But again, remember, it's x over 2 equals that 3 pi fourths, right? And x over 2 equals that 7 pi fourths that you guys decided on, because it has that extra piece in there with it, right? So how do we get rid of that 2? Multiply by 2. So those will divide out, multiply by 2. Those will divide out, multiply by 2. Okay? So what is 3 pi over 4 times 2? 3 pi halves. And what is 7 pi over 4 times 2? 7 pi halves. Okay, but what was our restricted domain? 0 to pi. Are either one of those in that restricted domain? No, because they're both bigger than 1, right? So because of this, we don't have any. They all occur past that point.
Is there any way you could know that without solving through, or would you have to solve through?
You would probably need to solve through, unless you had a picture of the graph to look like at it, then you would see that that's not going to happen until further down. Okay. All right, so on example number 4, we've got cosine plus 1 equals sine. All right, so in this case, we're probably not going to be able to solve it as is because there's not anything for me to factor, even if I move it to the same side. And there's not anything I can replace cosine with to turn it into sine because it has to be squared, right? If it was cosine squared minus 1, then we would be good. All right, so let's say we maybe do square it. Let's say we square both sides of this equation so that we could maybe do something there. All right, well, cosine of x plus 1 squared literally means cosine of x plus 1 times cosine of x plus 1, right? Equals that sine squared of x. Well, if we were to multiply this out, cosine times cosine would give us cosine squared of x. And then cosine times 1 and cosine times 1 would give me 2 cosine of x, right? And then 1 times 1 is going to give us 1 equals that sine squared of x. Well, what am I allowed to replace sine squared of x with? 1 minus cosine squared. So then I'd have cosine squared plus 2 cosine plus 1 equals 1 minus cosine squared of x. All right. Now, I want to move it all to one side now, right? Because now we do have like terms. So to move the 1 over, I would just subtract it, right? But the cosine's negative. So to move it, I'm going to add cosine squared. All right? So then I do have some like terms for those over here. So I already had 1 cosine squared, and I just added another one to it. So we're going to have 2 cosine squared. No like terms with that middle piece, so that just stays 2 cosine of x. And then 1 and negative 1, those go away, right? Okay. So anything we could maybe simplify here? Anything we could maybe pull out of both terms? Okay, let's pull out a 2 cosine. So if I pull out a 2 cosine, I would be left with, right. And that is something that we could say is our 2 factors and set them each equal to 0, right? So do 2 cosine of x equals 0, and cosine of x plus 1 equals 0. All right. Okay. So for that first one, I divide by 2, but I still have a 0 over there, right? Okay. And where is cosine 0? Somewhere.
Pi halves, 90 degrees.
Okay, so at pi halves and at 3 pi halves. Okay. All right, and then over here we've got cosine of x equals negative 1, right? Okay. So you said at pi halves and 3 pi halves for that first one. What about where it's negative 1? Pi. And this one is restricted on the domain from 0 to 2 pi, so I don't want to say that it's repetitive after that, so this would be it. Those are all of our solutions, okay?